Okay, so if we integrate this first function here, you can separate it into different integrals. So that's 4x cubed dx, that's the first one, minus 27 times the integral of x cubed again. I probably should have switched that to x to the 4, but now I haven't done it. I'll leave it as x cubed plus 7 times the integral of x squared dx plus 2 times the integral of, God, that should have been an x dx. Sorry, I should have been an x in here. Obviously, I made mistakes, and that should be x to the 4. But anyway, plus 8 times dx, like so. So I separate them all into separate ones, and that gives me 4 times the integral of x to the cubed is x to the 4 over 4, minus 27 times x to the 4 over 4, plus 7 times x cubed over 3, plus 2 times this one, the integral of x is x squared over 2, plus 8 times the integral of dx is x, plus the constant of integration, and then I tidy it up here. So this one is, they cancel, minus 27x to the 4 over 4, plus 7x cubed over 3, plus these two cancel, the 2 and the 2 cancels, the 2 and the 2 cancel here, to give me x squared plus 8x plus c, and obviously I meant that to be x to the 4, but I can add these two together, so that gives me 4x to the 4 over 4 minus 27 over 4x to the 4, and you can subtract that to give you 23 over 4 basically. So that's what I'm going to give here. Because I'm running out of space, I'll just do it as 20 minus 23x to the 4 over 4 plus 7x cubed over 3 plus x squared plus 8x plus c. So how many got that? Obviously I've added in the x over here. You mightn't have added that in, but how many got close to that anyway? So the next one then is 1 over x to the 4. So we rewrite that as the integral of 1, I basically bring it up to the top, x to the minus 4 dx, and then it's just a case of applying the standard rule. So I add 1 to minus 4 to get minus 3, and I divide by the minus 3, and I get a constant of integration. So that is equal to minus 1 over 3x cubed. When I bring the result back below, because I have a minus 3 here, I can bring it down underneath, and it becomes plus x3. Now, if you get a bit confused by that, you can split that into minus 1 over 3 x to the minus 3. That's minus 1 over 3, 1 over x cubed, and then you can bring them together into 1. That's easier to understand. Okay, the next one here is the integral of 1 over x is the natural log of x plus constant of integration. Just be aware that if it's 1 over x without a power, the integral is 1 over x. Here we have x to the power of 3/4. So the integral of x to the power of 3/4 dx is equal to x, and I'm going to add 1 to 3/4. So 3/4 plus 1 is 3/4 plus 4 over 4, which is 4 plus 3, giving you 7, so it's 7 over 4. Divided by 7 over 4, that's your constant of integration, and then we can just simplify that by saying we can multiply. If we're dividing by 1 over 7/4, that's the same as multiplying by 4 times 4 over 7. So we can basically invert it. So it's 4 times x to the power of 7 over 4 divided by the 7 plus your constant of integration. Okay, the next one here is equal to the integral. I can take the constant outside, x to the power of 1/4 dx. So I add 1 to a quarter is a quarter plus 1 is a quarter plus 4/4. 4 plus 1 is 5, so it's 5/4. So that gives me 2 times x to the power of 5/4 divided by 5/4 plus a constant of integration, and that's the same as 2 times, and we can invert the raised power, so it's 4/5 x to the power of 5/4 plus, sorry, get rid of that there and put it here, plus the constant of integration, and that gives me 8. 2 times 4 is 8. 8 times x to the power of 5/4 divided by 5 plus the constant of integration. If we look at question 6, this is equal to the integral of dx over x to the power of a third. So you replace the cube root with the index to the power of a third. That is equal to the integral of x to the power of minus a third dx. So you bring it up by changing the sign. And then we have it in a position where we can apply our rule. So we add 1 to minus a third. So it's minus a third plus 3/3, which is equal to minus 1 plus 2 plus 3, which just gives us plus 2/3. So it's plus 2/3 divided by the raised power, which is plus 2/3 plus a constant of integration. And then we can simply invert the raised power to give us 3 times x to the power of 2/3 divided by 2 plus c. And then we can rewrite that, if I come up here, we can rewrite that as 3 times, open up, sorry, actually I'll do the other step first of all. It's equal to 3/2 times x to the power of 2 times a third plus the constant of integration, which gives us 3 times the root, and we have a third here, so that gives me the cube root, and we have a 2 here, so that gives me the power of 2 plus a constant of integration, and I still have the division by 2 here. So if we go over that again, we start off at x to the power, the cube root of x, which we write as x to the power of 1/3. We bring that up on top by changing the plus a third to minus a third. We then integrate it by adding 1, so it becomes 2/3. We divide by the 2/3. That's the same as multiplying by 3/2. And then we split the 2/3 here into 2 times 1/3. So the 1/3 tells us we're getting the cube root, and the plus 2 tells us that we're squaring the x inside the cube root. This is the integral of exponential times 1/3 of x dx. So it's x divided by 3, so it's x multiplied by 1/3. If we look at our formula in the maths tables, it basically says that the integral of k times x dx is equal to the exponential of kx divided by k. So if we follow that rule here, we have the exponential of 1/3 x divided by k, which is the coefficient, which is 1/3 plus a constant of integration. And of course, if we're dividing by 1/3, it's the same as multiplying by 3. And I'll put the x over 3 back underneath. That is equal to x to the power of 3, and we just rewrite this one as x to the power of a third dx. Now remember, x to the power of a multiplied by x to the power of b is you sum the powers, the a and the b. So we sum the two of them, so we do the same over here. So that gives us the integral of x to the power of 3 plus a third dx. So if we want to add 3 plus a third, we express the 3 as a fraction over 3, so it's 9 times 3, 9 thirds plus 1 third, and that gives us 10 thirds. So this gives us the integral of x to the power of 10 over 3 dx. And if I just move that out of the way, so have a bit of space. So then what that tells us is we're getting the integral. I'll just write it back up here, 10 over 3 dx. So you follow the rule. So you add 1 to 10 over 3. So 10 over 3 plus, and you express the 1 as 3 over 3, is 13 over 3. So that is equal to x to the power of 13 over 3. And we divide by 13 over 3 and our constant of integration. And that gives us 3x to the power of 13 over 3 over 13 plus our constant of integration. So the first job is to use our rules of indices, express the cube root as a power, and then we add the two numbers together. So we're adding the 3 and the third together. And then when we integrate, we need to add 1 to that power, 10 over 3. So once again, we're using indices here. So this is x to the power of 1. This one here is x to the power of 1 multiplied by x to the power of minus a quarter. I bring this up to the top by changing the sign, dx. And therefore we follow the rule that we followed the last time, where x to the power of a multiplied by x to the power of b is equal to x to the power of a plus b. So this gives me the integral of 1 minus a quarter dx. So it's the integral of x to the power of 3/4 dx. So now by following this step, we bring the x to the power of a quarter up to the top. Then we add the two of them together, and now we have it in a position where we can integrate it. So we just say that is equal to, the power is 3/4, so we need to add 1. So that's 3/4 plus 4 over 4, and that gives us 7/4. So x to the power of 7 over 4 divided by 7 over 4 plus our constant of integration. And of course we can swap this around because it's 1 over 7/4. So it's 4 times x to the 7 over 4 over 7 plus a constant of integration. And I forgot to do it on the previous one, but we can then split that into, I'm going to just cross it out here and go up to the top because we're running short of space here, to be honest. So I'll come up here to the top here. I'll rewrite this as 4 times x over 7, and the 7/4 I write as 7 to the power of 1/4 plus the constant of integration. So I split the 7/4 here into 7 times 1/4. And once I've done that, I can then say that's equal to 4. I open up a root sign, and I know here it's the 4th root. And I have x to the power of 7, so I bring the 7 down like so. And I'm dividing by the 7 here. So that's how I express it back as a root, as a radical. This is equal to the integral of x squared. So our first step is we have the square root of x cubed. So that is actually a tricky enough one to get. It's x cubed to the power of a half. Okay, the half is coming here because it's the square root. So that will give me the integral of x squared times x over 3 over 2 dx. I have a dx here. And this then will give me the integral of x squared times x to the power of minus 3 over 2, because you bring it up to the top. So the tricky one here is inside the brackets, the x here is cubed. So that is x cubed multiplied, and the square root gives you to the power of a half. Therefore, that's 3 over 2. I then bring it up on top, so the plus 3 over 2 becomes minus 3 over 2. And then it's a case of adding these, so it's 3 minus 3 over 2. So I express the 2 as 4 over 2 minus 3 over 2, which gives me a half. So this gives me the integral of x to the power of a half dx. And then I go ahead and integrate that. So a half plus 1 is a half plus 2 over 2, which is 3 over 2. So that gives me x to the power of 3 over 2 divided by 3 over 2 plus my constant of integration. And then that gives me 2 x to the power of 3. And I'm going to do two things here because I'm running out of space. I'm going to invert the 3 over 2 to 2/3, and I'm going to express the x as 3 times a half. And that enables me to say we're looking for the square root of x cubed. The half tells me it's the square root. I don't need to write the 2 in. By default, it's there. And the 3 tells me that I'm cubing the x. And I divide by the 3 there. Okay, so they're very like this. It's very like the stuff we've done in video 6 today. Question number 11 here is equal to, if I multiply it out, is equal to the integral from 1 to 0 of x times 1 minus 3x squared dx. So basically I multiplied the 1 by x and the minus 3 by x to give me minus 3x squared. I can then split these into 2. So x times dx minus the integral, I can bring the 3 outside, going from 1 to 0 of x squared dx. So you can see you can split these if you have a plus or minus between them into 2 separate integrals. I then integrate x, so it's x squared over 2, and that goes from 1 to 0. The upper limit is 1, the lower limit is 0, minus 3 times, and the integral of x squared is x cubed over 3, and that goes from the upper limit of 1 to the lower limit of 0. So then this gives me, if I do this, gives me 1 squared over 2 minus 0 squared over 2. So the 1 is the upper limit, the 0 is the lower limit, minus 3 times 1 cubed over 3 minus 0 cubed over 3. So you plug in, for x, you plug in the upper limit, minus, and then you plug in the lower limit. So this gives me a half minus 0, minus, and this gives me 3 times 1 cubed is 1 over 3, so it's 1 over 3 like that. So that gives me a half minus 3 over 3, which is 1, which is a half minus 1, and a half minus 1 is minus a half. Okay, this is the integral. Now I don't have to separate them. I can do it all in one. So if I say that is the integral, I could do it all in one step if I want. So I'll just do it again here. So I'll put my brackets here. And this is 2 times the integral of x squared is x cubed over 3 minus 3. So I write out the constant here. And then the integral of x is x squared over 2. And then I plus 4. So it's plus 4 times x. And that goes to my upper limit here, which is 2, down to my lower limit over here, which is 1. So this tells me that I have 2 times 2 cubed over 3 minus 3 times 2 squared over 2 plus 4 times 2. So that's where I put in the upper limit. And here then I can put in the lower limit. So it's 2 times 1 cubed over 3 minus 3 1 squared over 2 plus 4 times 1. So if I work out, I'm going to have a load of fractions here. So 2 times 2 cubed is 8. 2 times 8 is 16 over 3 minus 2 2s are 4, 3 4s are 12 over 2, which will be 6, plus 4 times 2 is 8. And that's minus, here I have 2 times 1 cubed over 3, so it's 2/3. Minus this one is minus 3 over 2, and this one over here is plus 4. Now I can put everything here over 6. This one here is going to go to, obviously 2 into that goes to 6. So if I put everything over 6, I think I'll put everything over 6 because I'm going to have 6 over here anyway. So three goes into 6 twice. 2 times 16 is 32. 2 goes into 6. I won't bother. I'll leave this as it is because I'm putting it all over 6 anyway. 2 goes into 6 3 times. 3 12s are 36, so it's minus 36. And 8 6s are 48. So I put the first one all over 6 minus, and I'll put everything here over 6. So 3 goes into 6 twice. 2 times 2 is 4. 2 goes into 6 3 times. 3 times 3 is 9, so it's minus 3. And 4 times 6 is 24, like so. So this gives me 32 minus 36 is minus 4 plus 48. That gives me plus 44 over 6 minus, and here I have 4 minus 9 gives me minus 5 plus 24. So 24 minus 5 is 19. So it's 19 over 6. And I take this away from that and I get 25 over 6. 6 goes into 25 4 times and you're left with 1 over. So it's 4 6 is 24 plus 1/6. It's 4 1/6. This one here is equal to the integral from 1 to 0 of 6 times x to the 4, so multiply these two together, minus 2 times, and it's x to the 4 times minus 2x, so it's minus 2x to the 5 dx. And if I go ahead and integrate this, 6 times x to the 4 is x to the 5 over 5, minus 2 times, and x to the 5 is x to the 6 over 6. And that goes from 1 to 0. So if I just tidy that up a little bit before I do any calculations, that gives me 6x to the 5 over 5, and 2 goes into 6 3 times. So that gives me minus x to the 6 over 3, going from 1 to 0. So I can plug in that one. So it's 6 times 1 to the 5 over 5 minus 1 to the power of 6 over 3 minus 6 to the power of 0 to the power of 5 minus 0 to the power of 6 over 3. So straight away, everything in here is going to go to 0. And that gives me 6/5 minus 1/3. So I need to put it over, the lowest common multiple is 15. So I write 6/5. 5 goes into 15 3 times. 3 times 6 is 18. So, and then 1/3. 3 goes into 15 5 times. 1 times 5 is 5. So that gives me 18 minus 5 is 13 15ths. So we do this one here, the last one here of these definite integrals. we just multiply it out. So x squared times minus 2x is, sorry, I made a mistake there, is minus 2x cubed, and then 3 times x squared is plus 3x squared dx. So I go ahead with this. It's minus 2 if I integrate it. Just bring my constant down. And x to the power of 3, the integral of that is x to the 4 over 4. Then we come to this one, bring down the 3, and x squared is x cubed over 3. And that's going from an upper limit of 2 down to 1. So this gives me, if I tidy it up, 2 obviously goes into the 4 twice. So it's minus x to the 4 over 2. The 3 and the 3 cancel. So it's just nice simply plus x cubed going from 2 to 1. So therefore, if I plug those in, that's equal to minus 2 to the power of 4 over 2 plus 2 to the power of 3 minus, and we have minus 1 over 2 plus 1 cubed, and sorry, 1 to the power of 4. Now, if you look at this, 2 to the power of 4 divided by 2 is minus 2 cubed, which is 8. But you'll see that these are going to cancel. So we have minus 8, and here we have plus 8. So that lot there is going to go to 0. And here we have minus, and we have minus a half plus 1, which is plus a half. So it's minus times plus a half, which is minus a half.